Even if you're not a physicist and have never taken a physics course, physics is part of your life. Your smartphone uses semiconductor chips based on quantum mechanics. If you have ever had an X-ray or an MRI scan, you've benefited from medical techniques developed in physics labs. If you care about clean energy and maintaining the environment, or worry about the chances of nuclear war, physics hovers over those issues as well. And if you have ever looked at the stars in the night sky and wondered, as we always have, how they and all creation arose, the science of physics has answers. From consumer devices to research at the edge of the unknown, physics is woven into our daily activities, our civilization, and our highest aspirations. It is a foundational science that is massively supported by society and underpins other science and technology. Yet this essential human enterprise began long ago, and at a small scale, in the minds of a handful of Greek thinkers who wanted to understand the world around them. Curiosity and understanding. If there is a constant theme that runs through the history of physics, from its early days as natural philosophy practiced by the ancient Greeks to today's intricate theories and apparatus, it has two strands: curiosity about the natural world and the belief that we humans can comprehend it. Our early ancestors were surely astonished and awed by the natural phenomena around them, from the rising and setting of the sun to the ceaseless sound and motion of the ocean. Those feelings must have been accompanied by the desire to understand what they saw. We still feel wonder at the beauty and workings of the universe around us, but with a difference. Now we can explain much, though not all, of what we take in with our senses or through specialized instruments. We continue to seek broader and deeper understanding, and today we have the tools to satisfy that curiosity, tools whose development is a large part of the history of physics and of all science. Physics and nature. The connection between physics and nature is embedded in the very beginnings of the science, whose name comes from the Greek root physis, meaning nature. But the tools that formed modern physics took a long time to evolve. Our early ancestors believed the workings of nature to be under the arbitrary, sometimes capricious, control of gods, such as Zeus, the chief Greek Olympian, who punished other gods and mortals when they challenged his authority. That belief in the gods came to be replaced with a set of concepts and techniques that would coalesce into physics, an integrated approach to exploring the universe. Chief among these ideas was, and still is, the belief that we can grasp the workings of the world through the rational exercise of the human intellect. This was a major change from believing that the gods could do as they wished beyond human knowledge or control. Closely related is the idea of cause and effect, the conviction that a physical action in the world, such as the application of a force, gives a predictable outcome, and that the same cause always produces the same effect under equal conditions. Other necessities to develop a science of physics were careful observation and record-keeping of natural events, such as the regular motion of planets and stars. Later came quantitative analysis. Mathematics became the language of physics, the most powerful, concise, and exact way to manipulate data, express physical ideas, model the world, and predict its behavior. Two other prerequisites were the notion of the experiment, an artificially limited portion of reality designed to test a particular idea, typically combining observation with the recording of quantitative data, and the development of a theoretical physics that uses mathematics to analyze and explain physical behavior and experimental results. These elements did not come quickly or in one place, but over millennia in different nations and cultures. In one example that became woven into the fabric of physics, before the Greeks, the early Sumerians, Babylonians, and Egyptians developed measurement methods and applied mathematics. The Sumerians and Babylonians produced